Welcome to another edition of Comet Algebra. This video is for Algebra 1, Chapter 2, Section 7, Solving Multi-Step Equations. What they have added in this section is they have put variables on both sides of the equal sign, both sides of our equation. Now we'll have variables on it, so we will need to take care of that before we solve. So several things to do. We have distribution, we have combining like terms, we have to get all the letters on one side, the numbers on the other side. So I kind of put this in a list format. Step 1 says simplify both sides by doing distribution and combining like terms. So that we already learned. But now we take a look at it. We're going to have numbers on both sides and letters on both sides. Using your undoing method, because not only can you add and subtract numbers to both sides, you can add and subtract x terms. For instance, you can add a 4x to both sides or subtract a 10y from both sides. And by doing this, we want to get the variable on one side and all the numbers on the other side. And then after we do that, we just finish solving it using the undoing method. We would be, dividing on both sides. All right, so many different skills coming together here. So let's look at a couple examples. All right, in this first example, we're going to start by doing the distribution on both sides. Here we have 3 in front of the parentheses times x minus 5. 3 times x is 3x. 3 times negative 5 is negative 15. And then I still have this plus 4x equals. Then on this side, I just have this 6. I need to write that down. Remember, this negative sign is like a negative 1 that's being distributed to both terms in the parentheses. So that becomes a negative 5x and then a positive 3 because it's negative times negative. Next step is to combine like terms on both sides of the equation. So over here, I have a 3x and a 4x. That gives me 7x minus 15. And over here, I can combine the 6 and 3 and get 9. And I still have the minus 5x. So now we want to get all the x's together on one side and the numbers together on the other side. So it's a bit of your personal preference how you want to do this. It doesn't matter what side you bring the x's to. I'm going to choose to add a 5x to both sides. And by doing this, I'm going to have the x's just on one side of the equation. So over here, 7x plus 5x is 12x. Still have the minus 15. And here, negative 5x plus positive 5x is 0, so all that is left is a 9. Now I want to get the numbers together on the other side, just like when this was a two-step equation. So I'm going to add a 15 to both sides. And that would give me 12x is equal to 24. So when I do this last step of divide both sides by 12, I get x equals 2. All right, let's look at this second example. Sometimes when you're solving what looks like a pretty typical equation, it can lead us to some unexpected results. So let's see what happens with this one. Again, distribution comes first. Multiplying through by the 3 gives me 12x minus 15 plus 2 equals, now doing this distribution by 2 gives me 12x plus 6. All right, so far it looks pretty regular. Let's combine like terms. We get 12x minus 13 equals 12x plus 6. Now we want to get the x's together on one side. So if I subtract a 12x on both sides, now this may look a little unexpected. 12x minus 12x is 0. 12x minus 12x is 0. So what I'm left here is that negative 13 is equal to 6. Now, this is clearly a false statement. And when our algebra that we've done correctly leads us to a false statement like this, what that's telling us is that this equation has no answer. There's no number that we could put in there for x where this would be true. So the answer is that there is no solution. And that happens sometimes. There are equations written that no number satisfies the requirements of the equation. So we just write no solution, and that's it. All right, in our third example, again, looks like a pretty normal equation, and we'll do all the steps as we've learned, and we'll see where this equation leads us. So again, distribution, we have this negative sign that's being distributed. So the 8 stays as is, but we have then a minus x and a plus 4. And then over here we're distributing a negative 2, gives us a negative 2x plus 12, and then plus x remains at the end. So again, combining like terms, I can put this 8 and 4 together and get 12. So I have 12 minus x on this side. Here I can put my x terms together. Negative 2x plus x is negative x plus 12. And now when I add an x to both sides to try to get the x's together, another interesting thing happens. Negative x plus x is 0. We end up with 12 equals 12. Now this is very different from the past example we just did. This is a true sentence in math. 12 does equal 12. And when this happens, what that tells you is that this original equation is an identity, meaning any number that you put in for here for x and you did it, it would be true. Try it if you don't believe me. Put in any number you want for x and it'll work. You will get a true statement. So the answer to this question is that there's infinitely many answers. Any number works. So the solution is all real numbers. Okay? Anything and everything would work in this equation. All right, now you have the knowledge you need to do section 2.7. So have fun with that.